Lesson 10.6, writing scientific notation. So our key idea starts with 2 steps. Step 1 is to move the decimal point so that it's located to the right of the leading non-zero digit. So that means we want to start with a factor that is 1 point something, 2 point something, 3 point something, all the way up to 9 point something. Then we're going to see how far we have to move that decimal so it gets to where it belongs, whether at the end of a positive number or in the right place for a decimal number. So we'll count the number of places you move the decimal point. This will indicate the exponent to the power of 10 as shown below. So here we see our 2 examples. So when you write a number greater than or equal to 10, that exponent is going to be positive. And when you write a decimal number, the exponent is going to be negative. So our first example, writing large numbers in scientific notation. Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. So I am going to write the 165. Now I'm going to put a decimal in between those numbers so that it's between 1 and 10. So that makes 1.6. Now I'm going to use the number that was given to me in the problem, and I'm going to put a decimal there. And I'm going to count how far it has to move to get to the end of the number. So 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. And it makes a number greater than 1. So that's a positive exponent. So 1.65 times 10 to the 9th. Example 2 is doing the same thing, but we're going to end up with a negative exponent because we're looking at a small number. So the 2004 Indonesian earthquake slowed the rotation of Earth, making the length of a day 0.0000268 seconds shorter. Write this number in scientific notation. So I'm going to write 268, and now I need to put a decimal in, so the number is between 1 and 10. So that's 2.68 times 10 to a number. And again, I'm going to use the number given to me in the problem and count how far does it move to go from 2 where it belongs behind the 2. So that's 1, 2, 3, 4, 5, 6 spaces. So my exponent is negative 6. Right now, you'll need to pause the video and complete those 6 on your own questions. Example 3. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive an award for selling 10 million copies? So without scientific notation, this would be a subtraction problem. So we're still going to subtract the 10 million minus 8,780,000. And when we do that subtraction, we end up with 1,220,000. So that's the number we're going to write in scientific notation. And I'm going to ignore those zeros and write the 122. And place your decimal so it's between 1 and 10. So that's 1.22 times 10 to a power. So I'm going to go back into the number that I got when I did my subtraction. And I'm going to move that decimal, and it needs to move 6 spaces to the right to get the number I want. So 1.22 times 10 to the 6th. And that's letter C. Moving on. What if the album has sold 955,000 copies? How many more copies does it need to sell to receive the award of selling 1 billion copies? Write your answer in scientific notation. So again, we need to subtract 1 billion minus 955 million. No, whoops, 955,000. And I can't subtract here. I'm going to do some borrowing. So that becomes a 0, 9, 9, 9, 9, 9, and 10. And now I have the numbers to subtract from. So 10 minus 5 is 5, 4, 0, 9, 9, 9. So we're going to need to sell 999,045,000 more albums to get to 1 billion album sales. So that number is the number we're going to write in scientific notation. So I'm going to ignore those zeros in the back and write 9, 9, 9, 0, 4, 5. And we'll have to place a decimal, so it's between 1 and 10, so that's 1, right behind the first 9, times the power of 10, and I'm going to go back into my answer when I subtracted, put a decimal there, and count its movement to get to the end of the number. So that's skipping past 1, 2, 3, 4, 5, 6, 7, 8 spaces. So 9.99045 times 10 to the 8th. Our last example is a real-life application. So we see that the table shows us when the last three geologic eras began. Order the eras from earliest to the most recent. I'm just going to remind myself, earliest to most recent. So down here, I'm going to show that the Paleozoic era was 5.42 times 10 to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. So that's 542 million years ago. The Cenozoic era, I hope I'm saying that right, 6.55 times 10 to the 7th. 4, 5, 6, 7. So 65,500,000 years ago. And the Mesozoic era, I keep saying era, 2.51 times 10 to the 8th. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, now we're comparing these three numbers. So the earliest one is the Paleozoic era. Notice that it has the highest exponent with the biggest factor. The next one is the one that also has 10 to the 8th, and that's the Mesozoic era. Leaving our last one, the most recent, the Cenozoic era. And notice the last one had the smallest exponent. That's it for today. Hope you had all of your answers answered.